Hey, Jose. Jose, exactly.
Yeah, exactly. Absolutely, Mr. Bean.
Mr. Bean, the four dimensional bean. So we had a chat about object-oriented programming, and
Absolutely.
yeah, and we what we actually discussed was almost like hexa- hexagonal architecture, right? This is the term.
This is kind of the yes. This is what is described in what Alistair Cogburn describes as hexagonal architecture, or also sometimes port adapters architecture,
Yeah.
or his name. Bob Martin also wrote a book called Clean Architecture. I think this is the last book that was written in this series of
Mm-hmm.
attempts to bring principles to how you should organize the architecture. But when they're talking about architecture, it's merely how can you organize your modules, how can you organize the communication between them,
Mm-hmm.
and how you can organize the dependency between them. That is,
Mm-hmm.
what module should depend on what module. You see,
Mm-hmm.
uh, the backstage principle would be that, of course, you don't want your application to depend on the fact that you are going to use MySQL to store your data, for instance. That would be really a mistake to do that. You don't want your business code, the core of the implementation of your business logic, to depend on the implementation details, like the fact that you're using JAX-RS for your REST services, or the fact that you're using Hibernate to communicate with your database,
Okay.
and this kind of thing.
From the puristic point of view, we mistake. The question is, can we live with mistakes or not? So this is the question. And I had already a fight. Yaroslav Tulach, the guy. So we had a very similar conversation like with you, but he builds NetBeans, right? So and he was very strict about interfaces, and I always told him, I don't care about your interfaces. I don't have such problems in my business applications. And this was like, it was our conversation went almost south. But then I said, okay, look, you're right. I mean, you have complete different requirements than in my business applications I have. For instance, if I'm in an Oracle shop, right, and I need some Oracle features, I would absolutely use the Oracle features. Actually, in one project, we need the Golden Gate features, which were not available. I mean, we needed them. So okay, then we just use it. So we even dropped the JDBC. I think we used some Oracle classes directly, and it worked, and I was happy. So of course, we've wrapped this with an interface with a static method because it's an easier, but it will be a class. But we didn't even try to hide, the fact that we use the Golden Gate feature from Oracle. Why not? Because there is no such a thing in MySQL, for instance, right? So if we migrate from Oracle to something different, I mean, we will have to rewrite the application anyway, because the different thing will come with complete different behavior. And this, I think, in the entire decoupling story, what we should also consider, that we can, leak abstractions, right? So this is what we should consider, because over time, sometimes the entire paradigm, I don't even know how to call it, so changes that instead of reading, let's say, a result set, we get a JSON back, right? So result set is more or less a reference, and JSON is a value. So if it changes completely, then whatever we did, all the abstractions are actually no more valid. But this was just I tried to recap the conversation. So we have the interfaces surrounding our domain models in the middle. And what I tried to find last time, or just explained what we did, is that polymorphism with object is sometimes great. And if you combine it with transparent persistence, what it means is that you get domain objects which are attached to the store. You can actually have a nice experience if you know what you are doing, but you have to really know what you are doing, because you have to be a domain expert. Then, and you should also write, clean code. I mean, code where if you look at the code, you know what happens from business perspective, and don't care too much about funky technology. So the idea would be you are just working with domain objects, and the next step would be even kind of DSL, right? So if you could go a step further and say, okay, I could create with a builder pattern, I can, for instance, create nicer domain object graphs. So this could work, but what I don't like even to to promote this, because this works great for very specific applications, and I see less and less such applications in the wild. What usually happens, and this is where what I would like to start to talk about data-oriented programming, is that we get from an external service, in my case, almost always is a microprofile REST client, or more often even now is HTTP 11 client, because it's lightweight enough. So it's very simple, with two-liners to get the string back. And you get a JSON object, and it is usually without any inheritance. I would say it is uncommon. I cannot remember in recent years in such an architecture that we inherited anything. It was just, plain Java objects, and now are Java records. Inheritance is very rare, I have to say. So, and now the question is, how to be efficient in such environment. And I would say I didn't even knew that data-oriented programming is a thing. But what I did in JavaScript all the time, I destructured directly the JSON objects. So what I got back is, okay, nice, I have 50 attributes, but I'm also only interested in 3. So I picked the 3 attributes and did something with them. This was absolute natural approach. And if we take a look at Java records and instance of patterns and switch patterns with the expressions, we are almost there with Java, right? We can have, I think you're not far away to have similar experience with Java. So
yeah, exactly. The fact is, I mean, the fact that your object model is built on inheritance, it's not really the concern of the business processors. I mean, it's very, sometimes it happens, and it's probably not the best experiences I had when working on a business application. You see, but when you're talking to a business expert, he will tell you, okay, we got this object. Suppose it's a contract object, and that person is not talking about objects. We have a contract, and this contract is carrying this, and this information. All right, describes like 4 or 5, and then with this information, we're going to do to conduct this process to transform this contract into a non-signed contract to a signed contract, for instance. And this person is describing you the process of signing a contract. But then when you take all these processes that could be specified by different people, by the way, usually it's merged into, we have a contract, so we are going to make one contract object, all right, stuff all the state that was described by these different people in this object. And because for some reason, yes, but between the contract object and the product object, we have these fields that are in common, so we are going to factor them out in a subclass, abstract class, I don't know, you see, and you end up having this kind of inheritance stuff, because the underlying assumption is that your code will be simpler if you don't repeat the same information in different objects. All right, which is a technical point of view of thing, technical point of view about what these objects are representing in the real world, because it's not because a failed, or let's say an element of state of 2 of these contract and product, for instance, are called the same and they look the same from the technical point of view, that they will evolve in the same way in a long time. And I'm failing to find an example in my mind. Maybe it will come later. But suppose that you have the same element of state specified in 2 different ways, and for technical reasons you say, okay, that's actually the same field in 2 different classes, so I'm going to create an abstract class and put this field once in my model instead of having it twice.
This was discussion from last time. So I have two examples. Maybe they fit well. The one was with the functional network. So there was like signal carrier, and the signal carrier was the abstract class, and the signal carrier had attributes or qualities like latency or something like this, and this was common to all signal carriers. So and the same was true was a transportation system. I don't know how we call it, the link between cities, maybe not a street, but something more,
like a road,
something like a street, let's say connection, right? Connection between cities.
Okay.
And the connection that also average speed. and average speed is common, for everything, because on with a bicycle, average speed is maybe 30 kilometer per hour, and the highway is 200, or in France 80.
Well, that's a discussion for
How fast can you go on a French highways?
Highways 130.
Yeah, very reasonable.
We have two levels of speed limit: 130 and 110.
Mm-hmm.
And if it's not a highway, if it's not a motorway, if it's a regular road, it depends on where you are in France. It could be between 80 and 90.
Okay.
And we are not talking miles per hour, right?
Kilometers per hour, yeah. And this is a constant then in the French. You have somewhere, an interface.
90 miles per hour would be really fast.
Yeah.
So you see, if you have these two pieces of state that are actually evolving in different ways, in 3 years, you realize that actually what was factored out were actually two things that looked similar, but that were not quite the same. And now you have a big problem, because you have an element of state that is stored once in your object model, and you will need to split that. And to do that is actually very hard, because you're going to continue living with the old version of that element of state. And in the future, you have something that will live along with it, that will you will need to take into account this new way of implementing it, and not the previous one. And then
you are just too pessimistic, because I think if you know what they are doing, you've been very efficient with object-oriented programming, but we have less and less opportunity to do it right. Because what you are assuming with the contracts, that you can also in charge of the contracts. What happens to me often, we have to access, an external system, and we get some data out, and it is not nice what we get out. And then we try to deserialize it to a JSON, and then pick, whatever interests us and make something reasonable. So I'm assuming, the external systems, I always have, unfortunately, external systems. They give me data, and which is maybe even good, but it doesn't fit my domain model. This is the bounded context you referred the last time.
Yeah.
I always have to retransform the thing, and doing this with objects is really bad. So this is what I really hated. So this is what was maybe completely misunderstood in all enterprise projects, because what people did, they mapped the first one to an object, then created a mapper, and the other one from the perspective of the other objects. But I was in projects, okay, the other one is just, the data layer. And we cannot be depending on the data layer. So they mapped it once, and then the mapped is the second time, not to expose the data layer. So we get a client object. So I was in project with that client object, the our data object and the foreign data object. And there are two mapping layers. And the Python and JavaScript people look at us like, you are all crazy. You are mapping the entire time. Where is the business logic, right? So, and this is what I'm talking about, is this complete misunderstanding of object-oriented programming, which cost a huge efforts, actually, to maintain that.
Yes, absolutely.
Yeah.
That's the reason. No, I mean, you're right. I totally agree with what you just said. And that's the reason why I think, if we just take a look at what records are, which is really a very simple concept, actually. If you just take a look at that, it's a simplification of that, because when you're designing a business process, or you're writing your business logic, what you're just saying is, okay, I just need this chunk of data, maybe, I don't know, 5 or 6 fields in a record called contract or product, whatever, client. Okay. And then you are going to send that to your, virtually, of course, send that to your data access layer, let us call it like that, whatever it is. And this is the job of your data access layer, to map the data that it has to the correct fields of the record you specified as your business logic, and to send it to you. And for that, you just need these two elements. First, an interface. Hey, this is what you need to implement. And second, the record. This is where you need to put this data so that I can consume it.
Exactly.
And if you do that, it means that your business logic module, the module of the modules that are carrying your business logic, are at the center of your application, where they should be. Okay, and everything else depends on them, right? So if your data access layer changes, Like for the moment, you're just accessing some kind of NoSQL database plus some REST services, whatever, and it changes because this is what technical stuff is about. As your business logic, you don't care. It's just a matter of changing the implementation of the interface that you sent, that you specified actually, and you are in the exact same situation as the situation we were talking about last time, which is what you don't care about how these JDBC interfaces are implemented. What you only care about is the interface itself, and the fact that the MySQL driver or the PostgreSQL driver is changing or is upgrading, fixing bugs, moving from one version to the other is not your concern. You just take the jar, put it in your class path, reboot your application or module path, reboot your application, and that's it. And you don't even have to recompile the core of your application. So that's really I think the best thing, the best way to work actually. But this is I've seen so many. You started saying we should be okay with writing mistakes, but I think that we should be okay to live with mistakes that were made in the past, not necessarily by you, but that you still need to handle.
No, but with promotion of interfaces on the hexagonal architecture, I'm afraid that someone listen to the podcast and then I will see even more mapping layers. I see just mapping in Java with recursive mapping and mappers, DTOs, mappers, and then I say everything is problematic, and then introduce Lombok to make it a little bit nicer. And
no, you don't need. If you're using records, you really don't need Lombok.
No, I know it. So at least this is what we agreed on, right? So this is Java records are great. As a small excursion, because I'm really curious what you will say about my approach now. What I do more and more in very specific cases, and the cases like serverless applications where you call them, they wake up and they go to sleep. So there is no shared state or something like this. I use 80% of interface. I use interfaces a lot, but without implementation. So I misuse interfaces just to have static methods as functions. And this works great, but it looks like C almost, right? But I mean, because this interface, it just has static methods, and this is enough. And I know there is no instance, which is very good. I like this more than have a Java class with private constructor and to say this is just never instantiate that and have then static methods. So for me, it's clearer on to use an interface with static methods. And for specific cases, it works great. And what I also did recently, but I'm almost actually yesterday, a Java record with method from JSON, and I pass a string and it reconstructs itself. So it calls the constructor, and the constructor is the compact constructor. The validation happens, and I have to say I really like it because I will not change there's a little bit dependency between the record and the JSON library, which I use is JSONP, which is standard. So this is not my concern because this JSONP is already more or less an interface. And so I would say in your eyes is a mistake because my puristic record depends on the edge, but it's very pragmatic and I don't have to create another class. I'm very cautious of creating too many classes. I start with some.
Why are you cautious of creating too many classes?
Why?
Well, yeah.
Because I'm working in a project with usually in teams, and what happens then if you allow just the creation of classes, it is hard to name them correctly. And if you work with external companies, so what will happen? An architect sooner or later will get an idea to name something after convention, and the convention is often like customer delegate, customer VO, customer mapper, customer entity, and customer DAO. So everything is customer. It's like, okay, but I mean, I would like to have a customer validator class or, customer data access. So something which in the name reveals the purpose. And this is the reason, actually. It's not that I don't like classes. It's more like if you start dirty and spend more time naming, then the next class will come with higher quality. But if you start with 5 classes, they are usually less cohesive. So this is just the experience. So right. So this is
if your record is specified on the business side. That is, I am designing the business process of signing a contract, and I design an interface with the method that needs to be implemented by the data access layer. And in this interface, I'm also specifying records with only the elements of data I need to carry on with the process. And you are the implementer. I give you the record. And because you cannot extend it, then you will have to put your JSON mapping code or whatever. It could be XML mapping code, by the way, outside of this record, because I am the one who is designing the record. And I don't, I mean, if I do that, I don't care that your record is actually specified by a JSON object or the data is coming through a JSON object.
But what you
XML
are assuming, but you are always assuming that the client from my record is another Java module. What happens in my project, the client of my record is JAX-RS endpoint, which exposes this to JSON, you know. I know why we have a different point of views, because so I thinking in request response, I go deep, come back, and sometimes I'm optimizing for what is coming back because I exactly know it has to be JSON in the project. Okay. And if the assumption is wrong, everything is wrong, right? So this is this thing. If the client will tell me in 10 years we have no more JSON but YAML, maybe we can adjust, but we have to think, you know, what you can do different in YAML in comparison to JSON, for instance. And this is maybe the difference. And how you think it is, you have a Java module and the consumer module is also Java modules, and they are potentially two teams in two modules. And this is not what happens in my project. In my project, my one module is a team, a small team, one pizza team, two pizza teams, and we are accessing something which doesn't belong to us, as a database or external services, and we're exposing the data to maybe a different team for the UI or to ourselves. But even ourselves is JSON. So on the other side, we have JavaScript usually, and we have to consume the JSON objects, right? So
yes, but in the end, it means that your business module, your business code, even if you're a small team, even if you're just one person, you can still follow this kind of pattern. I mean, it's not a matter of the size of the team. Of course, if you have big teams that are one in India, another one in Europe, and another one in the US, for instance, then having really good processes for these teams.
Yeah, this is important. Yeah, and my boundaries.
Even if you have just one person or two people writing your application, it would work also. It means that your business code, the code that is implementing your business, now depends on implementation details.
Yes.
And if these implementation details change, like moving from JSON to YAML or whatever, then you need to recompile and revalidate all the business logic. This has a cost.
Yes.
One of the costs is that you could have regressions in your business logic where actually nothing changed in this business logic. All right, there was no bug fixing, no feature, no evolution of existing features. So if nothing changes in your business module, then having to launch your non-regression test means that you probably have at least for me, you have a problem in the organization of your
yes.
Of your code.
So, and if you know your mistakes, it could be good or bad, right? So this is no. I see already. If you would be my manager, we spent a lot of time, fighting and less time coding.
I would tell you this is how you do it, and you. No, I'm kidding.
So then I would try, then I will leave the company, be promoted, come back to your company, and become your manager. It's like, look, no interface is forbidden in my project, right? So we build dirty code, but fast. No, yeah, it's a really interesting discussion, and in one time we should actually go through the code and try to dissect the code and say, okay, this is my point of view, and say, okay, but this would be even more interesting. But now, what really interests me is your point of view, take on data-oriented programming, because this is exactly
this is exactly what we're talking about. This is exactly what you're talking about, because suppose you are writing this code that is mapping your JSON object, which may be complex. You may have too many fields in it to fit in the records. Even the record you need to create actually depends on several different JSON objects with different informations coming from different places. And then you need to fit everything in a given record that is specified by your business logic internally, even if you are specifying the business logic yourself. It's another you. Okay. Data-oriented programming tells you your object should only carry your state. So basically, you design your records, and the only code that you should have in them is the validation code.
Yes.
You have a user record, and you need that the age is an integer, and this integer has to be greater than 0, probably lesser than 150, or something. See, this kind of simple, well, they could be complex, but only business rule. And everything else, and this is not what object-oriented programming is telling you. Object-oriented programming tells you, hey, my object should be able to write itself in some XML, JSON, YAML. It should be able to serialize itself. You see, and you end up having objects with many responsibilities, and probably responsibilities that will decay over time. Okay, objects that have been designed 10 years ago were carrying some code to write themselves into XML documents. Now maybe this code is not used anymore, and you have only and you had to add some JSON stuff in it. Okay, but because it is baked in the object, everything depends on that, and it's very hard to remove it. Because actually, if your application is big and monolithic, which is most of the time the case for legacy applications, it's very hard to know if this piece of code is actually executed at runtime. You can analyze your code statically and tell, okay, well, I have like 50 classes that are depending, that are actually calling this method. But the real question is this method actually called at runtime? And I worked on applications.
Then we have misunderstanding.
They had to move from 8 to 11. And by the way, the guys made a talk at Devox once and explained that. And in their application, they had, maybe you remember that, a CORBA module.
Yes.
All right. Remember CORBA back
yes.
in the days? All right. It was in the middle of the application, and this CORBA module was huge. And because of this CORBA module, they couldn't move from 8 to 11 because it was removed from the JDK, etc.
Mm-hmm.
So they had to remove this CORBA module. Is it called at runtime? Guess what? They didn't know. And even the old developers, the old architects that were there when the application was designed in the first place, didn't know 10 years after if this CORBA module was called. So what they did is that they took their sharpened razor blade, okay, to cut this CORBA module out of the application.
Well, you know what you did in the past to find it out? Another dirty practice, I will tell you. Mm-hmm. I'm curious about your reaction. So we ran, this was WebLogic back then, one node with code coverage, unit test code coverage. And we tested the entire application a few days. And then with the code coverage, we saw what was actually used.
Yes, but okay, so I'm going to tell you another story. This is what we did on another legacy applications. So we removed
no batch updates were a problem. Something runs once a month and you don't hit this is the problem.
Yeah, but sometimes it's not once a month, it's once every 6 months or once every 6 years.
No.
6 years, every year, every 12 months. And this is what happened to us. Okay, and some kind of bookkeeping process that was triggered only every 6 months showed up. Yeah. The code was not there. And then, fortunately, we had a good Git repo, so we could go back to old branches. So, okay, this all legacy stuff happens. Now, if you
but back to the record.
Yeah.
Just back to the record, because
absolutely. This is
I have a Java record, and what the Java record has inside is the crypto key from JavaX crypto key. But the crypto keys, they are not that usable. You need always some utility methods. Mm-hmm. So I put methods as derived attributes, to get from the crypto key my compress, decompress representation, whatever. And so this is a little bit of business logic, but from my perspective, derived parameters are okay on records. So, and the from JSON was not an instance method, it's a static method. So, and why I put it on the record is because depending on the internal structure of the record, the JSON object looks different. So the JSON object and the record have to match. So it is maybe cleaner to have a static method from JSON where you pass a string and create a JSON object knowing the components of a record, then creating another class, because this class, has to know the record and you're repeating some code in JSON. So it is from the maintainability perspective cleaner to have a static method in the record, because I immediately see which components are in the JSON object and which not. And I have unit tests for the records for serialization, deserialization. If I will put it outside the logic, my record will be cleaner because it will be completely independent from JSON. But the on every change of the record, I have to think about, to unit test the other class to have the match. So this is just a trade-off. So it's not like, I'm putting business logic on record. It's just in this particular case, I thought it works good. Of course, if JSON changes, I will have to do something about that. But the new projects are smaller. It's no more like, we build million of lines of code, we build more projects. So the trend is not you have one huge project, you have maybe 5 smaller projects. So this is at least my observation. So it's not like I'm building business logic like crazy. I thought about a lot. It was an external class and internal class, and records are new. But the feeling is what I got right now. It is a good decision because it's clean, less code, and easy to maintain and easy to test. But of course, I'm depending now on JSON in my core business logic. And in 10 years, maybe it turns out it's a bad decision. But for now, it's simpler, right? So this is always a trade-off. So this is wanted just to clarify that this is more like factory method, which is inside the record. So what I did.
The real question is, in 10 years, will your application still be there? But
Exactly.
Because if you think that it will be just thrown away in 2 years, then it's not a problem, really.
Exactly.
But I have a question about that. So you're telling me that from one JSON object, you are creating one record, but that sometimes this record does not depend on all the fields of the JSON object and not the same fields? Does it mean that in the components of your record, some of them are used in certain cases and not used in other cases?
In my case, it's very simple.
I understand.
We have to use an object storage, and the records have to be serialized and deserialized, and this is almost like JPA persistence. So I go to the records, I give me your JSON, I store this JSON, and I'm done, right? So this is basically it. And we don't use reflection, whatever. We could use what I could use, Java reflection, go through the components, do it outside. So this would also work. But reflection is slow and doesn't work with GraalVM, for instance, right? And we would like to have the option to. So this is the least possible magic I could came up with, and it is easy to test. But it is a mistake. By the way, I do lots of mistake on purpose, so it's like a trade-off, right? It's okay. It is not the puristic, not the puristic point of view, but it is better because what I would like to. I think the system is maintainable. So if you will look at my code and you ask me why you did it, and I explain it, and at least the explanation seems logical. I mean, there's no more to ask why. If you ask me why you did it, it's like because it's easier to test, and I show you I can explain it and not explain it because of decoupling, which I don't like. If someone asks you why you did it, because it's nicer and modular, I don't like the word modular because there is no business value in modularity. You can only have business value if you say we can maintain easier, move faster, we can decrease errors, or in 10 years we can switch from XML to JSON. So this is business value, but who cares about modules? No one, right? Interfaces, no one. We have to provide business value and do whatever is necessary to do so. So, okay.
I'm not sure what you're calling, what you mean by records. If you're talking about Java records in a Java 9 sense, that's another topic. When
Java records, not in 9 sense.
Module.
No, not modules in Java 9 sense. Modules in Java package sense. So like a business.
Well, I think the value is exactly there, maintainability. If you have a small application and maintainability is not an issue, it's not expensive, whatever you do, then you can just stuff all your code in one place and you don't care about the organization. But if it's not the case, then having good rules to separate your concerns in different modules and have a clean separations and clean boundaries between them is very important. Yeah.
Yes. I mean, even in small applications, we have Java packages, lots of Java packages with business names, but I have no problem depending on JSON in a JSON project. This is a trade-off. So this is, but I don't like to have one package with one class, which is huge, right? So the responsibilities are separated from business or domain perspective always. So this is the driving factor. Okay. Yeah, this is always the case. At least this is what why we are slower than usual in projects, because we think about names a lot. So what is the name of the package, the class? It has to be named. It has to fit well the domain. So this is where we spend the time. And if I wouldn't, for instance, right, I wouldn't depend on Jackson in my record, never, because the Jackson is just implementation. JSON B or JSON P is a microprofile standard, so it's more stable. So then I'm depending on it. And if we update from Quarkus 3 to 4, then maybe it is affected. But everything else is also affected, right? So this is maybe at the beginning of the project, what I try to do is to define what is my standard. What is okay, to live with, what we can depend on. So in a puristic Oracle shop, I would say, okay, if there's added features, I use just Oracle connection directly. If this is a not Oracle shop, it's just a regular business project, JDBC is a must. There is no COM, Oracle, whatever. It's not allowed. In a microprofile project, it's absolutely okay, to depend on microprofile interface. I wouldn't, wrap and microprofile interface with another interface. So there was a huge discussion. For instance, I always used the entity manager directly in JPA. I didn't even try, to wrap it just to be independent from JPA, because my idea was always, if this JPA changes in one point of time, we have a problem anyway. So because we are completely depending, and this is the thinking, and what I just noticed, that the majority of projects don't think about the business modules a lot, and they focus more on decoupling from technology. And I don't know whether it is the right strategy, right?
Yeah. Even if you have a JPA module, if you want to move from Hibernate to Eclipse Link, you're in big trouble. Yeah.
Yes, even if your interface is the same. This is the thing. There is nothing. If you just switch, the behavior is different. The session attachment and transactional behavior is just completely different. This is, for instance, an example where you could encapsulate your JPA as long as you like, and there's still leaky abstraction. So you are abstracting the wrong thing because the behavior changes.
No, it's not even about that. It's just that there are so many differences in the way things are implemented between Hibernate and Eclipse Link, even in a database.
But even JAX-RS, REST easy on Jersey, behavior is different. So in Jersey, you don't have to close, the response in the REST easy you have. Otherwise, your application will stop. This is always the case. So leaky abstractions are everywhere.
Yeah. Absolutely.
Okay.
But so once you have, if you go back to data-oriented programming.
So could you define very briefly what it actually is? So for our listeners,
it's about that. It's about considering that data and behavior is separated.
Mm-hmm.
Object-oriented programming tells you an object should be able to do things itself, okay, and you have inheritance. Data-oriented programming tells you your objects should only carry your data.
Mm-hmm.
Validation rules, because this is what makes your data safe, actually. And all the behavior is not in the declaration of your object, okay?
Mm-hmm.
And you don't have inheritance.
Mm-hmm.
Since you don't have inheritance is really important, and we talked about that last time, in object-oriented programming when you're dealing with interfaces.
Mm-hmm.
And it's not the inheritance of behavior or the overriding of a given behavior. It's more the inheritance of type, right? You have a JDBC driver. Its type is JDBC, okay, from a macro level perspective. So the type is JDBC, and you can have several JDBC drivers. It doesn't matter because it implements all the interfaces you have, and your code will work the same, hopefully, from one driver to the other. So the behavior is not in your object. So suppose you have this this contract object, okay, and you have a first process that is about signing this contract. The reflex people would have in the object-oriented world is to design a contract model object. So you have several kinds of contracts. So you have several types of contracts. Each of them will have probably different fields, common fields, but other fields that are defined in the subclasses. And then they will have common business processes, maybe with some differences from one type of contract to the other. And you imagine all the object model you are going to build with that, with different methods you can call, overridance, inheritance, overriding of methods, etc. design that. So the object from the object that's the approach from the object-oriented programming, and it has been working for years. So it's not that it's not working. It's also that it has a cost, right? And the cost is maintenance. We've been talking about that for a long time. I mean, suppose that you rooted the XML support
or core
classes of your contact or core bar, and then you need to get rid of it. Then you're in big trouble. Yeah. So it may never happen, and that's okay. If you're sure it doesn't happen, then don't have any problem. Just write quick and dirty code and throw it to the trash after a while, and that would be okay. Dump it and
no, but in serious, you say dirty code. The code will be clean if we assume if JSON changes, we have to refactor. This is clean decision, business decision.
Yeah. It's not a problem in itself. I mean, the problem with dirty code is that if is the cost of change. Okay.
Yes.
What is the cost of changing your code?
What is the cost if JSON disappears?
I mean, two things: fixing bugs. Adding features and removing features. So that's three things.
Yeah.
Okay. If fixing bugs is fine because your code is simple and it's easy to fix bugs, then that's okay. If adding features is fine because your code is not that complex and you're adding a feature, it's just a matter of adding a method in a class, that's okay also. But think about removing features, because if you can't remove features from your base of code, from your code base, sorry, if you can't remove features, it means that in a short term, you have a process. We talked about that. We have a process to add code to your application. You don't have a process to remove code from your application. So quite rapidly, you will end up with dead code that you will have to manage. So that there is a cost in that. And once again, if your application is bound to be thrown away in 1 year, then it doesn't matter.
Wait a second. Your argumentation is global. So what I see is my record with JSON. There's only one record in a larger project.
Yeah.
It's not like that we serialize all records to JSON. This is one specific case where I need persistence in this case. No other records are persisted to JSON. I know where I'm going. It's not like, this is like a best practice in the project and all the records are persisted. No, there's just one. So I would say I would be with you. So I wouldn't, just all business records are automatically JSON serialized. This would be terrible. So this is not the case. And even we have different Java classes, proper Java classes, because they are mutable, and there is no JSON persistence. So the JSON persistence happens somewhere else. So So this I wanted to clarify. Is this you are right? So you cannot, because the next step is I would build a JSON persistence framework, which will be in my records. And then everything depends on it, and this would be not that good decision, right? So this is more like it was an exception from the rule, and for that it's fine. So this is how I see this, and if JSON comes or disappears, so it affects maybe 2-3 classes, not hundreds, and this is absolutely okay from my perspective. And the code is then dirty best practice.
It's not the same.
Dirty best practice.
It's not the same.
Yeah, exactly. Okay, so now we understood a little bit, because your argumentation that something bad happens is like what could worst case and done in 10 minutes in any case is not, but it is not a general best practice to put serialization persistence inside your business objects, because if you not know what you are doing is even worse, because maybe your objects are not unit testable, You cannot, for instance, create a state because the connection is missing, whatever. This is terrible. So this is the problem. So the separation is a good one, and this was just exception from the rule. Okay, it was just an exception, but I'm absolutely with you. Okay, and now I also know where you are going with the interfaces, because in one point of time, sealed interfaces should come to our discussion, right? So this is like the longest introduction to sealed interfaces in the history of Java. I'm pretty sure, because we are the first, right?
The thing you need to understand is that if you don't want to put your business logic in your objects anymore, and this is what data-oriented programming is telling you, don't do that, then you need to put it somewhere. And you need to know, suppose you have 10 different kinds of contracts, and it was implemented in object-oriented programming world with inheritance. Now you have still 10 kinds of contracts, but implemented with records. So you say, but I have common fields in one contract and another. Okay, you leave that aside and you suppose that you do it anyway. You still have one problem to solve, which is, okay, I need to implement the process of signing a contract.
Mhm.
And actually, I don't have one process. I have 10 different processes. Okay, so 10, sorry. 10 different processes, one for each contract, that are implemented with method avoidance and this kind of thing. It can be very, very ugly, very quickly, this kind of thing. It can lead to very hard to understand code, very hard to read and stuff, because it's completely, entangled and intertwined. It can be really terrible. But now you have 10 contracts and you need to do something. So the first approach is to say, okay, I'm going to create a factory method, because this is how data-oriented programming is working. You put factory methods, and this factory method is called sign contract. It has to take a contract object as an argument, and then you're in trouble because you actually have 10 records to model these 10 different contracts. So the idea is to say, okay, I'm going to create an interface to I use type inheritance, which is not behavior inheritance, and use type inheritance to say I have one contract type that is actually implemented by 10 different records. And you're not allowed to put any methods. Well, the idea is not to put any methods in this interface. This interface is just there to mark the fact that this record is actually a contract and that you can deal with it as such. Okay. It's very different from what we're used to doing in
one question, because I had similar architectures before the sealed interfaces, and what we allowed before is like batch operations, So on this interface, we would allow, I know it makes sense, like operation like default methods on collection sometimes. So you have a default method which, for instance, goes through the super record and invokes validate everywhere.
You don't have super records because records cannot inherit. You don't have inheritance.
There's no super type, but you cannot. I don't have methods. Yeah, right. So what I thought, we could have mass operations on this interface, like validate everything, and we'll walk through, whatever. But it doesn't make sense because then the records don't have behavior, right? So this is. But what I'm curious whether we find a nice use cases to put methods on this interface for batch operations or mass, not single record operation, because a static always implies to me is more list on record super type, for instance. But I don't know.
So now you have a factory method that is taking a record a contract type implemented by a collection of records that you have, and you're going to deal with it. And the nice thing is that this factory method is not stored in the same module as your object model anymore. It's stored in your business module. So I told you that you had 3 problems: bug fixing, adding of features, and removing of features. If the signing of the contract is not a business requirement anymore, you can very easily remove these methods where it was extremely hard to remove the behavior from your object model if you're using object-oriented programming. So this is something that data-oriented programming is bringing you, actually.
So it means means you would remove the record from the interface.
No, you remove you can even you remove the factory method. You remove the factory method. And the factory method doesn't depend on anything. It lives with your business module. So if your business module is not needed anymore, removing it will also remove the factory method.
Yeah.
But the code in a factory method in object-oriented programming is actually implemented within the contract objects, within the contract, hierarchy.
What you did, you have an external factory, right? So external class.
It's an external factory. Okay. It's an external factory. It's external to your object model, and it lives in your business module, which is only logical when you think about it. Okay, so now how are you going?
And this would be contract factory.
That's the problem. Sorry.
This would be contract factory. Sorry? Contract factory.
Signing contract factory, much more precise than that. Actually.
Signing contract factory, and there will be other factories or just one?
Yeah, if you want factory per business process or maybe more.
Okay.
I don't know. Because you want to separate the concern, you want to apply the single responsibility principle. And this method has one responsibility, which is the signing of contracts. And that's it. If you have other processes like paying contracts, it's another factory, it's another method. It could even be another business module.
Okay.
So once you have that, you need to think about implementing that. And The nice thing when you define an abstract method in an abstract class or in an interface, and you forget to implement it in a class, the compiler will tell you, hey, this signed contract method, which is defined there, you need to implement it. You create a new contract type. Okay, but it implements contract, blah, 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 or it extends this abstract. You need to provide an implementation for this method. So this is nice because at runtime, you will not have any problem of anything telling you, hey, you forgot to implement that, and you need to fix it. I have a missing implementation method at runtime. That's very annoying, but it will not happen because the compiler will tell you. And that's actually a safety net, right? So now you end up with an interface, a contract. You know that you have 5, 6, 10, I don't know, contracts, records that are implementing it. And you need to define the behavior, the business behavior of signing each contract for each of these concrete types. Okay, each records. So you end up with a very nice if blah blah blah, if contract instance of this type of contract, else if instance of blah blah. So you end up with the if else if, which is really ugly. We will agree on that, and which is also very unsafe because if you forget a type, then you will fall in the else branch where nothing is happening, and you have a bug in your application, and you will only detect this bug at runtime. You cannot detect it at compile time. So you move to a situation where the compiler was helping you, telling you, hey, you forgot to implement this method in that object, to a situation where the compiler doesn't tell you anything. So it's very bad. And that's why this notion of seal type was defined. Because now what you can do is say this contract interface is actually a sealed interface. And the idea of a seal type is that it knows all its implementations. Okay. And you're not going to use if, else if, else if, else if. You're going to use a switch. And that's the new switch that is able to switch on the types of your objects. And the switch on types, if you're switching on a sealed type, then the compiler will be able to check if you forgot a type or not. Or even if you are adding a case label with a type that is actually not an implementation of this interface. Okay. So now you have the safety you had with inheritance and the fact that you forgot the implementation of a method, of an abstract method, is given back to you in this approach, thanks to the use of seal types and switch. So you need to use both, actually, seal types and switch. And if you do that, then you will switch over all the types of this stuff. Don't put a default branch. You could do that, but the default branch will just be like an else branch in your if. That would be a mistake, because if you add a new type, then the default branch will prevent the compiler from telling you, hey, you need to handle this type also. So don't put a default branch. And then this switch type is like, it will tell hey, you need to be handled by this method. You don't need to put all your business logic in the switch type. You can just have method call to other factories. That's also a possibility, especially if your implementation is complex. But that's really the core of it. And once you have that, you have refinements. That is, instead of switching on types directly, your case labels can be patterns. So you can deconstruct your records to get the components of them directly. In the future, you will be able to define your own patterns on your own regular classes, not only on records, to deconstruct your own classes, with the possibility of having overloading and this kind of stuff. So it's something that is still a work in progress. This pattern matching code. This is what pattern matching is about. It's about deconstructing objects and being able to assign from an object. You just deconstruct it, so you open it, and automatically you say, hey, this field or this stuff should go in this pattern variable, etc. It's about initializing a set of patterns variable from an object. In records, it's done automatically for you, because you know that a record is built on components, and you can deconstruct a record and get its components directly. But on regular classes, you don't have that, so you will need to be able to have a syntax, to have a way to define your own deconstruction patterns. And this is going to come in the future. People are working on that currently, so we'll be able to do that.
We did something similar. And it was with NoSQL database, and I think we could call it data-oriented programming. So I try to explain what we did, and then we can agree whether it is or is not. So the problem we have with data with NoSQL database is there's NoSQL, and you have to search efficiently. So what usually happens is you have the primary key comprises two parts, and the two parts are unique. So you are misusing the second part of the key for type information or filtering criteria, whatever you like. So, and usually we encode there the type of the class. So what it means is the crazy part. In a SQL database, every row can be a representation of a different Java class, in our case, Java record. But the amount of Java records of types is, let's say, 7 contracts, what we said. So, of course, we have a constant, like a type discriminator, so we know what comes from there, right? But we need a kind of a factory as well, because what we have to do is we say, okay, the JSON coming back from the database matches only specific type, because some record can have more fields or less fields. This is the matter of the record. So what you get out of the factory, we call it store, or there's no good name for it. So I don't like the store, but it's actually could be considered as a factory or a deserializer. So you go there, you get you put the primary key, and it goes to a NoSQL database, and you get a record back, actually a sealed interface. And the sealed interface is implemented by your 7 contracts. This works, but the really cool part is now in all the other parts of the applications, it looks like JavaScript almost, because what we can do is we can have a method with this with the super contract type, how to call it, the sealed interface type, just contract, blank contract, not signed contract, whatever, it's just contract. So now we are talking because we can use deconstruction, or this is not deconstruction. Java is just how you call it properly. Deconstruction is JavaScript term. In Java there is a different term, but sounds
people are talking about deconstructions of records. Yes.
In JavaScript is destructuring, or in Java is deconstruction. This is the difference. Okay. So destructuring is JavaScript term. So I forgot the JavaScript term. And so now it comes. We can have a method with the sealed interface type, a method, let's say process. In the method, there's a switch statement which switches on the sealed interface type. So because this is sealed interface, it is exhaustive. So we are forced to have all cases and default, but default is more or less forbidden. So because if your default is falls through, is a little bit problematic. But in the case statements, we can deconstruct. And what deconstruct means is we can say, if instance of the record, we can pick whatever variables we need for this process, because you don't need everywhere everything, right? So we can have and this is almost like a reasonable visitor pattern, because you could have multiple such processes depending what you would like to achieve. And this works great. So what I started to use the instance of pattern before Java 21 for actually JSON. Because if you use JSON-P, you get JSON value back, and this could be JSON string or whatever. And there was always annoying with the, and now I could say instance of and get the right type, which was really convenient in a switch statement, for instance. And now with Java 21, we have the next iteration, and it works particularly well with NoSQL databases, actually, because it is really ugly to deal, with such a thing. But with Java reconcile interface, it works really good, and it looks like JavaScript. There's almost no code. And I think this is all kind of data-oriented programming, what I'm doing with NoSQL, right?
Yes, what you're describing looks. I don't know exactly how it's working, but it looks like data-oriented programming. Yes.
Hey, cool. So
data-oriented programming is not a new thing. It has been. There are people who wrote articles about that like 15 or 20 years ago.
Oh, okay,
so I thought this was a new idea.
Okay.
No. Java doesn't do any new thing in this kind of topic. Java is not about testing new stuff. It's about stealing
old stuff.
Stealing old stuff if you want.
Okay.
Great artist steals,
Yeah, and appreciate, right? No, and
if you want to conclude on this part, because what you can do, the biggest difference, and this was studied by a university professor called Phil Wadler in the University of Edinburgh. He wrote books about it. He also wrote books about functional programming a very long time ago. He's not a young man. And what he described, that in object-oriented programming, as long as you don't have the hand on the object model, right? Another team is working on the object model, and you can also only use it. You cannot modify it. It's the nice thing with object-oriented programming is that you can create your own type by extending the existing types. But you cannot add behavior on the model, because the behavior is implemented in method within the objects, and you can override them, but you cannot add new behavior. It's not possible, because this behavior is implemented in classes. You cannot modify. And in data-oriented programming, what is interesting is that it's the exact contrary, because everything is sealed, everything is records, everything is completely frozen. You cannot create your own types. It's not possible. You get the types, you cannot extend them, you cannot add new types, but you can add all the behavior you need and remove all the behavior you need, because the behavior is in static methods that are depending on the seal types, and the implementation the seal types are defining, because the seal types itself is defining its own implementation. So you cannot say, okay, these seal types, I'm going to add one permit and add my own type in it. This is not possible. In Java, actually, there is a very strong constraint, which is you have your sealed interface, suppose, and all the types that are extending these seal types should live either in the same module if you're using the Java module system, or in the same package if you're not using it, if you're using the class path.
Interestingly,
so the constraint is very strong.
You remember the signal carrier system I told you?
Yeah.
So I was there, and they tried to do it in data-oriented programming in Java. Pullman data-oriented programming in Java back then, with lots of value objects. They call it value object or data transfer object actually, and instance of and mappers. And I actually was able to prove that this is what they would like to do is impossible from effort, because the amount of classes would explode back then. And the problem they had is, if a new signal carrier comes on the horizon, they had to find all the instance ofs in all their project, to react to the new carrier. Otherwise, it will just fall through. But this is solved with seal interfaces. So what was not, but
and switches,
exactly,
and switches.
Yeah.
If you do if else, you will not have this exhaustiveness.
And this is the entire conversation, 3 hours what we had. The problem they had, they wanted to have not objects, they had a data transfer object with type, and they tried to find, if you are this type, I would like to behave this way with instance of everywhere, and this was absolutely not maintainable, and with the entire mappers. So, and I said, and then we solved that with object orientation. And in this particular project, it was actually great, because if new type came in, we just subclassed. It came automatically from a database. What I described right now, it was the job of JPA persistence. This was on Fat client, which was a good idea back then. And so what it meant, actually, we worked with live objects. So the objects were attached to the entity manager. It could be modified from outside, and we say commit, and it was serialized to a database. So the other project with the transportation system is not that common that we get new road types. In this particular project, this data-oriented programming, even back then, would be a big win. What I remember, the object model was not that great. So, but the cool story is, in the signal carrier project, I had to work with Smalltalk developers, and they were stellar in object-oriented modeling. They knew that they were accustomed, to think in objects. In the other project with the transportation system, the object model was not well designed. It was designed without any thinking, like at school. We have vehicle and abstract vehicle and transport, abstract transport. Just lots of classes without thinking about that. And the problem they had were validation rules. What happens if the transport is overloaded and it is on the wrong load? And this was the thing with data-oriented programming. In this project, it will solve that, because it would be separated. We could have different validation rules for different transport and for different roads, right? So this was interesting consideration. And I would say right now, most of the projects are data oriented in the thing, because I don't even have the factory. I get the data from outside and I try to serialize data from outside to map it to Java records, and then I have the type, right? You know what I mean?
Yeah.
So it occurs. So I don't even think about data oriented programming. I'm just doing this. If there is no need for inheritance, and if it works, you are fine. You will notice that when you need inheritance, if you have no, I think inheritance is interesting if your persistence also supports inheritance. So it means what you get out of your persistent store without any additional manual work is already an abstract class or interface, but you get actually the subclass with different behavior. This is perfect. If you have to do it by yourself, forget it. So then this is maybe the remaining part where I think the object-oriented programming has its parts. But data-oriented programming is very important. What I also miss, but is coming, how to call it, not mutable records, but there should be a possibility to create a new record from old one, right? Instance.
Yeah. This is coming actually. This is called withers. And you say, okay, I would like this record with this field or with this stuff, and then it will create another record. Just like in functional programming, by the way. In functional programming, everything is immutable by design.
Yeah.
So when you want to mutate something, like a list, something, or a map, actually don't mutate it. What you get is a copy of the previous one. And internally, there is this super smart implementation that actually doesn't duplicate your structure in memory. Just
I like the immutable collections back then, right?
Or immutable maps. It's really amazing to see how this is working.
I hope we covered now data-oriented programming, and it's really interesting.
At least we talked about it.
Yeah, and I know why we misunderstood us the last time with interfaces, because if I see interfaces, I see the misuse. I see in projects where they just this is not in object-oriented way. They have something and they just put an interface in one implementation. But what we talk today is like types. So we introduce interfaces to have types, and we seal the type to have exhaustive switch statements. So the compiler will be our friend. So this is the entire thing, right?
The compiler should always be your friend.
We have to tell it to JavaScript developers.
It works with switch statement, but also with switch expression. Now you can. The switch is both a statement and an expression. So
I always have expression. I forgot to so my new switch statements is 80% of cases expression. Why? Because if you get the record in the switch statement and you pull some variables, deconstruct the record, you usually create a new one, and the new one is immediately returned, for instance, from the switch expression. So it's always about expressions.
Exactly.
It's almost like a view projection, almost, right? Would it be projection? So it's actually projection what happens. So one record in, data mingling, and another out. Projection will be without business logic, right?
Mapping, adaptation. I don't know. Projection.
Okay.
Projection is a weird name to use in this context, I think.
The last question, which has nothing to do with data programming, but you have a nice French car. It's called the DAC. Is it also called the DAC in French? It's like the Peugeot, so an old one from Louis Define. This was his car.
Oh.
Which it looks like so in German we call it DAC to it. So it's like a Citroen V2. It's a classic car, an old one.
Oh, this old car that was completely dismantled in the first scene of a
exactly.
Okay.
Is it also called DAC?
No, in French it's called la deux chevaux, which means 2 horses, literally. What translation? Because it was 2 horsepower. It was very small engine in it. Almost an engine for a bicycle, actually.
Okay.
But the car was so light that it was working. Oh yes, this car is actually a legend.
I know it.
It was designed in the 30s for the army. It was designed from the ground up to be able to drive in fields and
like a French Hammer, right? So it was like
dirt paths, not necessarily on roads, and it was built until the 70s, I think, or something. There's even a James Bond movie with a car chase.
Okay.
And James Bond is driving such a car, which is amazing because it's
Okay, that's cool. Then
that would drive at like 50 or 60 kilometers per hour maximum.
this would I ask about the highway speeds limits, whether it was about the dark car, but I didn't know whether you will understand me. So it's okay. I will wait until the end.
Yes, but I see what you mean. It's oh yes, this car. Actually, if you own one, a real one, then you're probably rich because people are collecting this kind of car now, and it's quite precious.
Okay. Cool. So on that note, I think we covered everything now,
I can
right?
tell you, it was so uncomfortable.
But I think how to call it, the suspension looked good actually in the car. It was very soft, right?
Very soft because it was supposed to be able to drive in dirt roads and the fields and this kind of thing. So the suspension had to manage that. Yes.
Yeah, very good. So
very weird car in nowadays standards.
Thank you a lot. And where people can find you on the Java news Java Dev YouTube channel and whatever you have.
Yeah, exactly. Well, if you check the Java YouTube channels, just youtube.com/Java, you'll find a lot of content by Nikolai, by Billy Corando, Nikolai Parlog, Billy Corando, Anna Maria, myself, and of course other people. We publish content there quite regularly. There are different series, different programs, different length of videos that you can check. I have a series of shorts that is 1 minute videos. So if you really don't have the time,
and one will come with data-rated programming in 1 minute, so you have to speak fast.
We have quite a lot of content on data-oriented programming, like C types, etc. Yes, Nikolai did that.
The challenge to you is explain it in 1 minute.
Okay, challenge. I think I can do that.
Okay, perfect.
I mean, it's a simple concept. When you think about it, it's a simple concept.
Yeah, it is.
Field types, immutable data types, the records fits well, and switch expressions and pattern matching.
Yeah, this would be cool.
So it relies on these features, and it's amazing because you could see each features individually, but they actually fit together in a much bigger picture. So taking a step back and having this big picture is actually. There's much more value in understanding that in that way than just seeing them as separate features and that you can use one by one to write better code.
Perfect.
It's not just about adding syntactic sugar to the Java language. It's also about implementing a new approach to design your applications.
Then thank you a lot, and
thank you.
See you next time.
Absolutely. Thank you, Adam. See you.